Getting started, I just wanted to open with one interesting observation we have been doing. So when we very first, and it's already a couple of years back, started with our Cumulocity IoT Edge, so thought about wouldn't it be cool to put all our capabilities and have them easily deployable on any industrial PC on a shop floor. We were thinking about that the typical customer journey would be you would actually want to start in the cloud and connect your device to the cloud because central device management is much easier than deploying a distributed IoT architecture and then having your kind of different deployments at the edge. And then once you've got more data to process, once latency is a big issue, you would actually want to move your processing closer to the cloud. But what we're actually finding is that, especially for our customers who are very often not just using our platform themselves, but also building services for their customers. You spoke about smart equipment manufacturers, so Lenis as a also service provider for different industry customers also is a great example. We find that more and more customers are actually confronted with a situation where they tell their customers, well, we have this great services, remote asset monitoring, so you can connect your equipment and we monitor it for you remotely. We send the data to our cloud and then you can log in and see how your asset is performing. And then, we heard it before, directly the CISO cries out, and no, we cannot do that. We cannot have the data leave our factory. And that's what we are seeing a lot, that actually we see everybody wanting to migrate and to build up cloud systems, but in a lot of cases that is not feasible, mainly due to security concerns. And that is why we see actually now many customers who start the IoT journey on the edge, and then once also their security practices mature, they actually find out how to step-by-step also move data into the cloud in a secure manner. And that is what we, with Cumulocity, also always have been focusing on to support as best as possible for both ways, starting in the cloud and moving to the edge, but also starting in the edge and then moving to the cloud is what we call the develop once and deploy anywhere paradigm. So we deploy exactly the same architecture across cloud and edge and all the extensions, the applications you can build on top of Cumulocity, a UI application, a microservice. You can deploy exactly the same applications also down to the edge, down to your industrial PC. And that makes it very easy for you to start in the edge and then move your workload up in the cloud or the other way around. And then, of course, we also have the SynEdge as an open source framework, which also makes it much more easy to manage workload, to manage software services on IoT gateways, on soft PLCs. You have seen Canvas before. So to actually make it very easy to do local data processing and actually manage also the workload on the cloud. And that is actually exactly what the presentation today is about. So on our IoT Edge platform layer, so Nick is first going to speak about our Cumulocity IoT Thick Edge offering, so our whole platform bundled on a single industrial PC on the edge. And we are talking a bit about what's actually the difference between the cloud platform and the edge platform. And Nick will also show a bit our recent progress in moving to Kubernetes and hosting not just on virtual machines, but also on Kubernetes clusters. And then Ruben is going to give an update on ThinEdge, so our framework, or the open source framework that we are investing in for IoT gateways and soft PLCs, and show how you can set up ThinEdge in 90 seconds. I'm very much looking forward to this demo, because after today, each of you who is interested in ThinEdge IO, you can install it in less than 90 seconds. At least that's the promise. Let's see if you keep it. And now handing over to Nick to speak about Cumulocity IoT Edge.
Thank you, Nico. Am I audible? All right. Can you please switch? Yeah, thanks. So yeah, thank you. Excited to talk to you about IoT Cumulocity Edge. But before that, let's have a brief look into on-premise story versus edge. Who has heard about our on-premise offering of our IoT cloud platform? Who runs on-premise? Yeah, at least one. So I would start with the similarities, right? It's awesome. You can develop it for the edge, or the other way around. You can start in the cloud and bring all of your applications and connectivity and integrations that you have delivered and developed for your use cases. And then use either cloud, on-premise, or thick edge. So the similarities are clear, but what are actually the differences? And this we get quite a lot. Why would I run on-premise if I can just run thick edge? And why would I run thick edge if I can get high availability on-premise? And that's one of the first major differences. We do not offer high availability on thick edge. So also thick edge is a single node deployment, usually as a virtual machine or on Kubernetes, and we'll have a couple of slides about Kubernetes offering that we deliver with in just a couple of months. Yeah, for thick edge, updates require downtime, so it's not like what we have in the cloud. There you should really reboot your machine and perform all the changes. So, super excited to share with you Kubernetes, thick edge on Kubernetes. Just the question, who runs Kubernetes in production, maybe for some other software? Kunbus guys? Two? Interesting. Let's catch up after this presentation, because it's also interesting for us. What can we offer for you not to run any additional software in the future and reuse your Kubernetes infrastructure that you have already? So currently, thick edge offers single node cluster, single node deployment, and you can run core services either as part of your Kubernetes and Mongo as well, so database of Cumulocity, either on the same Kubernetes deployment or as a separate Mongo database, which covers you with some disaster recovery use cases and things like that. We say that we deploy into Kubernetes CNCF certified, so Cloud Native Certification Foundation, but there is a caveat to it. We test with K3S, which is Rancher's offering, and AKS, which is Azure Kubernetes Cluster. So yeah, looking also for the customers that want to have it on different distributions. And we use Helm as a package manager for Kubernetes packages to bring actually this deployment to your Kubernetes cluster. Who has tried to install thick edge or on-premise Cumulocity? No one? One? And that's the software AG employees. So it's 118 manual to install on-premise, 118 pages manual to install on-premise. I will show on 2 slides how to install thick edge at this point. Starting in 1 month now, we have public beta available. Definitely have a look at GitHub repository that describes all of the steps that I will talk you through on stage today. So I've mentioned we use Helm, and there you just add your repository. So on the local machine, you download all the charts, Helm charts, then you initialize it and install, and that's the first step. After that step, you will have installed Edge operator on your Kubernetes cluster, and then with just one command, Kubernetes apply our Edge manifest with the license, and then get all of the pods, and hopefully you will see all the MongoDB database as part of your running in your Kubernetes cluster. There are a couple of pods. Maybe let me show you how it looks like in a real cluster. And that's the reason I've asked Kunbus guys, what's the resources we get. So if you have 8 GB RAM, if you have 4 CPUs, we can install Kubernetes cluster and run thick edge. So yeah, let's, yeah. Definitely. I don't know if you can you read, can you see what's on the screen? Make it bigger. All right. So what you see here is an active deployment of thick edge on Azure, on AKS. And we have here a couple of pods. If I would select namespace my core, that's interesting. Let me probably refresh. Oi, oi. Yeah.
Try tethering your phone. That's what I had to resort to.
Yeah?
Yeah.
That's the great network Boris was talking about.
Let's give it a try. All right, I believe you would need to trust me. So what you would see there is actually all the pods deployed in our AKS with MongoDB, with logging, with the microservices. And the coolest part about it, you can run your microservices now kind of outside of Cumulocity, but still on the same Kubernetes cluster. You can connect to them. And that's also discussions we have quite a lot right now with our customers in terms of high availability. What parts of Cumulocity really require high availability? So if you think about device connectivity, maybe northbound, southbound connectivity. So yeah, it opens up definitely quite interesting use cases. And if you are running Kubernetes already in production, you would be a perfect customer to test it. So looking forward to it. And the last but not least, so Kubernetes offering opens up interesting changes also on the thick edge side. We decided, well, since we now container-based, maybe we can exchange components on the thick edge side, like internal components, and we decided to go thin edge to connect to the cloud. And this will also be available in the next releases. And this would save us a lot of effort and bring more reliability when we can connect thin edge to the cloud and use it as an agent to control thick edge deployment. And to answer why we do it, I would give the word to Ruben to talk about thin edge.
Yeah, perfect, thanks. So I'll have a crack at my laptop, but I'll still use the presentation there. Okay, so hi everyone. My name's Ruben Miller. I'm the product owner for thinedge.com, or .io, I don't know, yeah. So I wanted, it's going to sound a little bit like a sales pitch. It's not meant to be a sales pitch. I just guess I'm really passionate about this project. So I just wanted to discuss a little bit what is actually thin edge. So thin edge is a I want to say a framework, but I think framework's the wrong word. So because it's a product, so it's an open source product that offers out-of-the-box functionality coupled with being able to customize everything. So you still get, for the normal use cases, you can apply, so install Debian packages to the software management plugin. But if you have some kind of new other format, you can just write a small composable component, and then you have it. So that's at the core, is this kind of extensibility and making it easy and just applying, just having to write small little modules of code to then make it easier to connect your device then, or your edge device, to the cloud. So when I say cloud, I really mean the cloud. So we don't really say, oh, only to Cumulocity IoT. It's really to AWS, Azure. We don't want to dictate what cloud you want to use. So our tagline is officially cloud agnostic. I personally don't like cloud agnostic because that's a bit naive. You think every cloud can do the same functionality, which is in reality not the case. So I rather much think about it like cloud hybrid solutions. So today's day and age of devices, there'll be some kind of different price points in different clouds where it might be cheaper to pump data in this direction for, I don't know, analytics or measurements, and then maybe device management and Cumulocity, or vice versa, or whatever. It kind of changes over time. So by having a solution which is, can utilize the best of all kind of cloud offerings, it kind of opens up new business opportunities. So you can really be adaptable with your business cases and your requirements as they come in, and they change over time. So you can really then make the most of it and really minimize the time to market and then really deliver value to your customers. So short, if you're writing an agent, stop. Use ThinEdge, please. Because I was one of those people. So about 2 years ago, I was working the Schindler project. We wrote an agent which pretty much is going to, all the functionality will be coming into ThinEdge. So device management, so software, firmware, configuration, measurement, but still with a more open interface to make it even easier to connect new stuff, child devices, and everything. So maybe just a few kind of technical notes. So ThinEdge is actually made up of multiple components. So we've chosen to write it in Rust because we really want to apply these devices or be able to install these components on low-level devices. So we're still focused on ARM set of devices, ARM and AMD 64, because we really see that's the future of a lot of the devices, not the ultra-low powered devices, but it's a kind of general trend. A lot of the IoT stuff is coming with ARM. And so being Rust, you have this memory safety guaranteed because it will not compile, even though the developers kind of yell and shout at the barrel checker sometimes. Those know something about Rust will know what I'm talking about. So you can really have that guarantee, and that with memory safety, you have this kind of security aspects which are built into the, and when it's a central component, you really need this stuff. So it's an added benefit, so it's building on kind of secure fundamental building blocks. Then also at the core, so it's a little bit hard to see on the diagram, but for all of the communication locally on a device. So we have ThinEdge, which is maybe running on a gateway device. We use a local MQC broker for the local communication for different components to then either listen to messages flying around on the device and react to them maybe, to then bridging that MQC local broker to the cloud, whether AWS, Azure, or Cumulocity. So by being able to have this kind of local message queue on the device, that opens up a lot of additional wonderful opportunities to then have this kind of synergies in between different individual components that you can kind of build your own event streaming stuff just from listening to the local MQTT messages. Or like yesterday in the hackathon, we did a flight recorder that just recorded all the messages sent on the local TEDGE interface. So TEDGE is short for ThinEdge, where we were able to record it and then replayed it on a different device, and then suddenly we have a device simulator. with very zero effort. I think we did it in about 2 hours. So by having this kind of openness, and we just use the open kind of or JSON format for the messages, so it's really, really easy to kind of listen to the messages and format and integrate it with other components. So I wanted to give a bit of a brief overview of what we've done in the last 12 months, because the project's been going on for about 2 years now. I joined as product owner in November last year. So in the last 12 months, so the big highlight that we just did release about 3-4 weeks ago now is that we had a bit of a refactoring on the project. So we did a bit of kind of switching to an actor-based model. Doesn't really sound very sexy, but believe me, it will have a massive difference moving forward, because it means we can easily write also the code for the agent itself in a more modular manner, which is easier to test. So it'll actually, I think, in the next 6 months, you'll actually find that our productivity is a lot higher, because we can actually develop new features which are more robust in a short amount of time. Then we also support like firmware updates for child devices. So because we're really pushing for this flexibility on, hey, you don't just want to connect your main device, but if your main device is acting as a gateway, you have child devices. So how do you coordinate some kind of extension for the child devices to handle firmware updates there? And so you can kind of implement your own logic, but then still benefit from the orchestrator of the thin edge component, which says, is the child's device still doing what it should be doing? And so you can implement components like that. So then we have like service monitoring. If you know Cumulocity, that is a fantastic feature to monitor the status of different services. Say, hey, is it up or down? And you can post measurements, etc. We have cloud remote support, so web SSH and native SSH are out of the box supported. External brokers, probably not so interesting. And then also self-updating within Edge itself. And so the roadmap in terms of, I like to call it the roadmap to 1.0. So we're not 1.0 yet. I'm a little allergic to the term. People go, oh, you're not 1.0 yet, because it's a very old software mentality, old school kind of thing. There's plenty of cloud software which hasn't reached 1 for about 10 years. But what we still realize for some customers it is a bit of a selling point. So we've basically highlighted a lot of points that we want to finish before we deem, okay, yes, we can bump it to 1.0. So one of these aspects is we want to do a bit of consolidation of plugins. So at the moment, if you've used Thin Edge, you probably have about 3 or 4 different services which run and then interact with each other. We're looking, so after the refactoring to the actor model, we can actually consolidate a lot of those components into one, while still allowing each individual component to run separately if you want. So this kind of composability is not only from the plugin level, but also in our internal kind of architecture, which I think is really, really important when you think long-term, think 2 years' time, you want to write your own Rust because everyone's Rust programmers now. And then that kind of opens up, hey, I can link in the actor library and then pull bits that I need, and then you have your own secure agent written in Rust with no other separate components. So that's kind of very important to kind of show this, and as a first kind of like indication what is then possible. Then we want to support containers as a first-class citizen. So we've already done a lot of kind of improvements over this time, being able to configure stuff via environment variables and all those kind of normal stuff that you do in containers. So you can also run Thin Edge locally on a device in a container, because that's sometimes a useful use case that some customers, if they want to kind of have an abstraction level that they sell their product and they say customers can install containers inside there. So you can kind of choose whatever abstraction level you want. But if you don't want to use the overhead from containers, you can also run natively, because at the end it's just compiled code. Then, so we are cloud agnostic. However, because we're, a lot of us are software AG employees, we still have a very strong push, or we also want to do it for ourselves, but to enable the remaining kind of missing device management features that Cumulocity offer, and supporting that from Thin Edge. So the two main things that come to mind are the firmware support for the main device, and also device profiles. However, when we talk about doing these features, yes, we're doing them for Cumulocity, but we're looking to abstract them. So technically, you could use another cloud to do that. So it's more it's really this kind of that sits at the heart of our team is this openness, and to say, hey, situations change over time. You have different requirements. Let's be open to it. It's a better design anyway. So having that kind of thin edge abstraction is then very helpful then to avoid vendor lock-in and stuff like that. So now that's probably enough talking. Now I'm going to go for my challenge where I'm going to swap computers. I think I'm going to have to check my internet connection first because it says I'm not connected. Seems to be a not very stable connection. Okay, I'm going to have to fast just to see how good my mobile network is. Whoa, it's terrible.
Awesome.
We'll see how we go.
We give you 95 seconds.
Yeah, we'll see. I have to set the stopwatch, obviously. Okay, so wait, let me just get set up. Okay. So terminal left-hand side, stopwatch, and then the instructions. So I'm just following. We have a demo container set up. So the idea is to simulate a device. So it's not a pure single, like a container in the sense. So it's a container that has like systemd in it. It's meant to simulate a Raspberry Pi. So yes, we know you shouldn't do this in real life. So please don't use this in production. But it's more to say, hey, what does thin edge do? I'm curious. This is kind of everything in the kitchen sink. So, okay, let's get started. Okay, let's start. So I'll get the Docker Compose first up. I'll have to read. So Docker Compose up. Okay. Then, so it's actually started, and then I'm just going to bootstrap it. It's asking me a few questions, so I'm just going to use a random generated device ID. Now let me just copy my password. Okay, so it's kind of going through the initial, so it started all the containers. So you can see there's like the main device and two child devices, because we figured, well, you might want to know how do child devices look. It's going through kind of like the startup, the bootstrapping, doing all of like the uploading the certificate. Still have 30 seconds, so it's looking pretty good. And so once it's done, it should spit me out a nice link to say, hey, do you want to actually go to my device in Cumulocity? So wait till the page loads, because I have time. Maybe not with the internet connection. It's close. At least it started, so technically I've already completed it. Look there, it's there. So now let's make that bigger. So now so this is new device. So we tried to think, well, maybe you want to have a randomly generated ID so it's unique. But obviously you can customize all that stuff. So it's really good for demo and to get to know thin edge. And this is what it was really designed to do. So what do you get? You get the main device, so that's connected to Cumulocity. And you also get two child devices. So here we also try to, because we want to inspire people how to write your own stuff. So actually on the child device, because usually child device is maybe done by a different team or a customer or something. So it's actually a simple Python script to simulate what a child device does. And all that is doing is creating an MQTT connection to the local broker. So it's not talking to the cloud. It doesn't need to know anything about the cloud. And nor should it, because it can live in an isolated network. That's fine. So we've also kind of tried to show how to, for example, do firmware updates. It's just mock data, so it's not actually doing much. So it just goes through the installation, and we have, it shows, hey, I'm applying a firmware update on the child device. And they go, oh, well, I've finished it in 10 seconds. So we have basically just created so it's all kind of really ready to go. because a lot of the time I find it better to have a working example, and then we can have something a little bit more tangible than just reading documentation, because no one reads it anyway. So it's good to have a kind of something you can play around with, especially if you know Cumulocity. You can see how we did this, and it's kind of living documentation. You can experiment, you can fork the repository, play around with stuff, and then you have something that you can already demo and use to sell to your manager to say, hey, we should be using ThinEdge. So we have maybe another, because I'm just looking at the time, I still want some time for questions. So if we just go back to the main device, some of these out-of-the-box features is like the remote access. So let's say we want to have like some access to SSH on the device. I can type. So I'm just going to configure I need to do a name. I want to say, I just want to connect through SSH to the device. What's happening in the background is I'm not exposing port 22, so don't worry on the device. The agent has the outgoing connection to Cumulocity, or like the broker technically. And I send this command, and then it establishes a WebSocket in between, which then is passing bytes in and out from the device. So that's a Cumulocity feature. So that means I can just start a console from the browser, and then I should have a shell that I can then just double check that I have the right operating system, OS, and I'm running a Debian operating system, Debian 11. So these kind of things, and this is immensely useful for troubleshooting in these kind of the normal scenario where you have 1,000 devices, have some problems on devices, check it out on the remote access, find out what the problem is, get a solution, then deploy the solution to your 1,000 devices or something. So there's a lot more stuff to demo. So it's really that easy. So hopefully that's enough for people to go, hey, I'll try it out, and then I don't need to show anything. But we wouldn't be anything without our community. So we have every 3 months a community demonstration where we look at kind of in context and customer context, hey, how do you use ThinEdge? And also like questions. We have like release demos. Everything's on YouTube. So you can really check it out. And because it's open source, you can actually check out all of the source code from our GitHub page and contact us there or through Discord. We're always reachable and very open to contributions or even questions. Contributions can also be, bug tickets. It's open source. So we're really open to contribute with anyone, and also happy to provide any advice when you need it. So I think that concludes my bit. So thanks. Then I would open up the round to questions.
So first, great job.
Thanks.
The question is, what is the adoption of this? Do you see an increase in the number of supported devices on your website? I mean, because Teltonica was mentioned here, right? I see cloud remote access, fantastic stuff here, but are the manufacturers adopting this?
So partly, personally, I would remove official devices from the website because it has nothing to do with the devices. It has something to do with the CPU architectures. So really, we support ARM 6, 7, 8, AMD 64. If it satisfies that, you're good. So we are pushing for a lot of, like with the device certification topics, where you have the nice stamps supported by Cumulocity. We're trying to reach out to all those partners to say, hey, what does your integration look like? Do you want to use ThinEdge? Because if you use ThinEdge, you get that stamp automatically. So it means you don't have to do much testing. And what we're really looking to also improve is it's a framework, but there's a lot of like bits around it, like how do you do integration testing automated? So we provide a lot of tidbits that are actually quite, hey, this is how I do a full solution, not just that product, but how do I test my plugin? How do I assume my plugin's going to work with that? How do you then extend the demo to be in your context? We go much further than just the project. So we're hoping these are all selling points that can also convince then the device partners to actively then use our product. Because I hate reinventing the wheel. It's annoying, and it's just, if you do engineering, you're like doing the same thing twice as annoying. And so we're hoping that we can take this kind of the normal stuff away from the device partners.
And I also recommend you to have a look at the community content, because there's a lot of content also how to, for example, do code assist development on using ThinEdge, or how, for example, the Phoenix Contact PLC Next also has ThinEdge installed on that. We have a customer, Turk, who is actually using ThinEdge natively. So that was actually an interesting one. They said us, we are fully bought into ThinEdge and know also to Cumulocity IoT. So they did actually the decision for ThinEdge first, and know are also taking our platform. But for them, it's two different topics, and that's like really also showing that this open approach is working.
Yeah, because we really want to drive other people, so it's a community that someone does a generic plugin that is usable somewhere else, and then it's kind of exchanging of ideas, and not this, obviously not the IP-related stuff, but there's so much stuff that software developers do which isn't IP. It's just kind of normal stuff, and that would be super helpful for everyone.
So Turk, for example, a good example, they actually found a way to remotely deploy PLC handlers to the Cumulocity. Like they built a nice UI around it, so that they can very easily determine which data from the PLC do they actually want to get into their cloud solution. Makes it very easy also for their customers to say, I would like to have these data from the connected equipment into my cloud solution. And step by step, we are growing the community. So
maybe as a device manufacturer, we can say that ThinEdge just brought us to certify. I have this nice certified sticker with Cumulocity. So the certification is very, very easy with ThinEdge. I've been through the same thing with AWS, the same thing with Microsoft, and the user story for the ThinEdge certification, the Cumulocity certification, is way easier. So then you mentioned CodeSys. CodeSys is a product that a lot of our customers use, and we have a RevPy featuring CodeSys, and we see it not only with our device partners or even competitors. They look at ThinEdge very intensively, and we see a lot of software that is used on our systems that is also used with ThinEdge. So from my side, I can say, yes, it gains a lot of recognition, and a lot of people are trying it right now, so you will see many more devices with ThinEdge. The question that I have is a little bit different, because on the first graphics on ThinEdge, there was this nice Mender I/O point. And the only problem that I have with our devices is when you have outdoor devices and some of the updates go wrong, then you brick your device and you have to have somebody to go there and to fix it. So what we really need is the possibility to revert back to the last working state, and to have over-the-air updates where we just send the data, the delta in terms of the new images, so that we can make an update on that.
I'll make it short because I know we're running out of time. Yes, we're tackling that. So we're looking to extend it exactly like we did software plugins, but with firmware, have a persistent state model behind it to drive in that kind of fallback scenarios, but it's also relying on other kind of firmware updates, so operating system update, technologies like SW update or Mender in standalone mode. Yeah.
Thank you.
I have experience with that, so yeah, we understand it quite well.
Cool. The Edge family, everyone. Thank you.